So welcome to our session 2 of the Math Professional Learning series. Last week we looked at why we do new math and kind of what that looks like for our students, and that we're working on conceptual understanding versus just a procedural understanding. And so today we're going to move forward in our series and do some addition strategies. We'll also look at a game that you might be able to play easily with students, or students could play at home, as well as a routine that maybe you could use with your students. So I, again, want to welcome you. We'll keep everybody on mute if we can. We are recording so that anybody who couldn't make the live session can view it later. You will get a contact hour for participating today. So at the end of our session, I have tried to make it a little easier for us today. I have shortened the survey that you'll do at the end of the session. We'll still have a small link or a QR code that you can scan, but if you need those contact hour certificates, please be sure to get those, either the link or scan the QR code before you leave today. If you have trouble with that, feel free to email me. My email address will be on the screen as well. I know that worked for some folks last week. If you participated last week, you all should have received your contact hour certificate by now. If you've not done that or haven't gotten that yet, please feel free to reach out to me and we can make sure that we get that to you. I'm very sorry for those of you who maybe got your certificates more than one time last week. Like I said, I've tried to streamline the process a little bit better so that hopefully I can get them all out to you throughout the week, but hopefully not as many duplicates will go out. Trying to learn on my own as well, and so I'm here to share that with you guys, so we're learning all together. So I'm going to share my screen. And you should be seeing a PowerPoint that just says session 2, addition strategies and routines. And if you give me just a moment, I'm going to pull up some screens. There we go. So when we think about standard algorithms, what we know as standard algorithms, when we do addition, we're talking about we stack and we add. Subtracting is that stack and subtracting make the trades. With multiplication, it's that stack, we multiply in the ones place, we put our placeholder 0 in, multiply across, and then we're adding, and division is long division. That's what we call the standard algorithm. And so when we think about where those standard algorithms show up in the Common Core or in our main state standards, which are closely linked with the Common Core, you might be surprised to see that addition and subtraction actually show up to fluently understand the standard algorithm is in grade 4. Now, it doesn't mean that we're not doing addition much earlier than that. We actually start some addition in kindergarten, first grade, but we don't actually see that standard algorithm until later, maybe even the end of second grade, third grade, before we're actually seeing the standard algorithm, and then they need to have that down fluently by the end of grade 4. So, and you can see there subtraction, we'll focus on subtraction next week, multiplication will be the week after, and then division. But some of you might be surprised to see that those standard algorithms aren't until much later, because we do introduce those much earlier. So we are going to take a look at a video. Last week we watched a video as well from Graham Fletcher from his website, gfletchy.com. And on this site today, we're going to actually look at his addition and subtraction progressions. And so it's addition and subtraction together, even though we're focusing on addition in our session today. You will see subtraction as well, because often we don't teach them independently of one another. We actually teach them together, and some of the strategies that we use kind of bridge between addition and subtraction. Even though we might have a subtraction problem, we might solve it with addition. It doesn't mean that we aren't using what we know about number sense. So we'll watch this video. It's about a 7-minute video, and you should hear the sound. If you're not, please let me know.
There's so much happening in the early years of school that at times it's hard to make sense of it all. So here's my attempt to make sense of the progression of addition and subtraction. So addition and subtraction begin in kindergarten when students begin to count. They begin to count objects and sets. They do this by counting forwards, and they also do it by counting backwards. A big thing to remember is when we're counting forwards or backwards that we include the number 0. And when we're counting backwards, let's not have them include blast off, because blast off isn't necessarily a number. As students work on counting, they begin to count sets. So here a student will have 4 in one hand, 3 in another hand, and they're not able to put those two sets together. There'll always be a set of 4 and a set of 3. Then as students move from counting sets to joining sets, they're able to combine the 4 and 3. So 4 and 3 more is 7, or 4 plus 3 is 7. As students begin to work on this idea of joining sets, we introduce 5 frames. And to be honest, I don't know if they get enough play in the early grades. So we'll have 4 and 3, and students begin to build an understanding of 5 frames and filling up a 5 frame. Students can see that 4 plus 3 is the same as 5 plus 2. And this understanding will build with students when they begin to use 10 frames later on. So in terms of subtracting, students can have 4 minus 3 and use a separate model, or they can also use a compare model. The big piece here is that a context should always drive the strategy that students are using. So as students are working on addition and subtraction, they're simultaneously working on this understanding of counting and collecting and grouping things in 10. So here 13 could be seen and should be seen as 10 and 3 more, or 10 plus 3. It's here that this whole idea of unitizing is introduced. It's massive, and we need to make sure that students don't leave kindergarten and first grade without this understanding conceptually. So as students dive into first grade, they begin to explore sums greater than 10. So what might that look like? Well, here, a student can take 9 plus 7, model it with a 10 frame, and because they've worked on this idea of unitizing, or they're beginning to, they know that it's most efficient to, say, fill up a 10 frame. So they take 1 from the 7, give it to the 9 to make a 10, and they're left with 6. Here students are beginning to think flexibly about numbers, and the same understanding applies to double-digit numbers. The big piece here is that students, as long as they're using concrete models, they're also drawing representations. So what did we do? We want to make a 10. So we're going to take our 1s and bundle them up to make another 10. Decompose the 8 into a 3 and a 5, give 3 to the 37 to make 40, and have 5 more. So what does this look like with subtraction in first grade? Well, in first grade, students are only subtracting multiples of 10. And here, 37 minus 20, they can see if they remove 2 10s, they're left with 17. So what happens in second grade? How does this build on what they've learned in first grade? Well, they might use two two-digit numbers. And here is where we begin to introduce base 10 blocks because of that whole idea of unitizing that students are still developing in kindergarten and first. Again, just like before, we'll draw a representation for our model. We'll create another bundle of 10. And here's how students can begin to move from the concrete to the representation to the abstract. Now, it might not be efficient, or students might see that it's not efficient to write it out on the side all the time. So to become more efficient, they can begin to use this understanding of partial sums and find a shortcut. 8 plus 3 is 11, 40 plus 30 is 70. And this understanding of partial sums, well, it leads brilliantly into their understanding that they begin to develop with partial products in fourth grade. So that works for addition, but does it work for subtraction? Well, we want to try and use models that continue to work the same and consistently throughout math. We don't want them to expire. So here we want to have 83, and we'll go back to that separating model. We want to put 29 inside there. Well, we need 6 more. So This is a really big understanding for students where they make that fair trade and that idea of unitizing. So now we can take the 6 from the 10 and we're left with 4. So how can we move again from the concrete to the representation to the abstract? Again, everything that we're doing here and all the work that we're doing, we're not undermining place value. And what's great is that this model, this understanding that we're building, well, it also applies to larger numbers as well. Now we can use place value mats, we can use just open sheets of paper such as this, but anyway, students are still acting out that fair trade and they're making sense, the regrouping of numbers. So what does this look like as we begin to write it as an algorithm? We'll regroup the 20 into a 10 in another group. It's all about students seeing the math conceptually, and we're not undermining place value. So as students dive into 3rd and 4th grade, they have 2 years to begin to formalize this understanding of subtraction and addition with regrouping and unitizing. But the big thing is that it's built through conceptual understanding. The standard algorithm isn't an expectation until the end of 4th grade, right before students dive into decimals with 5th grade. And you know what? In 3rd and 4th grade, if students need to use expanded form to make sense of what they're doing, let them do it. It's all about the conceptual understanding and allowing students to visualize the math. So there's lots happening. As we've said before, let's take our time. The turtle won the race. Love to continue the conversation on Twitter or hit me up on my blog. Thanks for watching.
So this was just kind of a quick overview of all the different strategies that you might see in some addition and subtraction, and we're going to go through each of those strategies individually. I do want to start with some of those hands-on manipulative pieces that are so important for students. And so I'm going to share with you a virtual manipulative so that you can see the manipulatives that I'm talking about, the tools that I'm talking about. So let me share here. You should be seeing, I'm on this website called toytheater.com. So toytheater.com. And when you come to toytheater.com, if you scroll to the bottom of the first page, you get these virtual manipulatives. And when I click on virtual manipulatives, there's all kinds of manipulatives that can be used with students or students can use. And so if you're working with fractions or decimals or clocks, there's all of those kind of materials. But when we start to think about our earliest learners, we start working with either a 5-frame or a 10-frame. And so if you teach in older grades, you may never have seen a 5-frame or a 10-frame before. I came from teaching 6th and 7th grade math and science, and I had never seen a 10-frame. I didn't know what that was until I worked with younger students. So if you haven't seen that, this is considered a 5-frame. So it sets students up to recognize what 5 looks like. And so in this case, students would use counters or chips, and you can put out different combinations. So here I would show 2 plus 3 is 5. I could remove them and I can say 3 plus 2 is 5, or I can say 4 plus 1 is 5. So that is what a 5-frame is. And then very similar to a 5-frame is a 10-frame. And so 10-frame is essentially 2 5s together, and you get your 10. And we typically fill a 10-frame from the top left going across because we know that that's 5. So we take that 5-frame model and we set it into a 10-frame model. So here we see we can have 5 or 6. Here we have 6 red and 4 make 10. Students also can recognize that they know that this is 10 when they see it. So if they see this box that has 8 in it, they might know that it's 8 by seeing 6 red, 2 yellow is 8. They may also recognize that this is a 10s frame, and so there are 2 empty boxes, so 10 take away 2 is 8. So they're starting to see that relationship between the numbers. So it's really based on conceptually understanding about numbers. They have number sense. And so that is a 10 frame. You might also see some students might use, or some classrooms might use, a rec and rec. This is something that I have used a little bit. Some folks love these, others can kind of give or take them. But again, you see the representation of this is 10. You know that this is 5. You can recognize this is 5. So those 5 all together, I don't need to count them, 1, 2, 3, 4, 5. I just recognize them as 5. So if I see this, I can recognize 5 and 2 more is 7. Or I can say 5, 6, 7. So using 5 frames and 10 frames and then the rec and recs are just ways to represent numbers where students are starting to actually have the concrete models to represent the addition problems that they're working with. We might also see students using their fingers. They always have their fingers with them, so they recognize that that's 5 very quickly. You have 2 hands, 5 and 5 is 10. So that's a great model for 10. One game that students might practice when they're working on their combinations of 10, because that's a first grade skill, something that we see very often, is combinations. Students are working on those numbers that make 10. We might play a game called fishing for 10. So it's just like go fish, but instead of asking for a matching card, so if I have an 8, I wouldn't ask for an 8, I would ask for the card that would make 10. So if I have an 8 in my hand, I'm asking for the 2. If I had a 5 in my hand, I would be asking for a 5. If I had a 1 in my hand, I'd be asking for a 9. And so instead of having matching pairs, you have a combination that work to make 10. And that's a great way for younger students to practice working on making combinations of 10. While I have up the virtual manipulatives, I do want to show you the number grid. So we're going to use a hundreds chart. Last week in the video, we saw that some hundreds charts actually go from 100 down to 0, or they build from the bottom up, so that students are working in the direction in which they're either adding, so they're moving up, or if they're subtracting, they're moving down. I'm just going to use a standard 100 chart. So if a student is doing addition here in first grade, we know that they're working on adding 10s. So if I'm starting with the number 24, students will learn that adding 10 more means that we're adding 1 row, which means that we're transitioning down one row on the chart, so it's 34. We also start to look for patterns in our 1s and 10s. If we're adding on, if we were at 34, and we are adding on 12, we know that 12 is a 10 and 2 more 1s. So we can add on a 10 and 2 1s. So 34 plus 12 is 46. And so that is one way that we use that number grid. Students start working of moving around this number grid very fluently. They might have 42 and they're adding 25. So 42 plus 25, I'm going to add on 2 10s and 5 1s. So it's really understanding the number sense. They understand the number. 25 is 2 10s and 5 1s. So 42 plus 10 plus another 10 is 20, 21, 22, 23, 24, and 25. So 42 plus 25 is 67. So it's a model for students to use. They're working on addition. they've got a model and they've got some sort of tool that they're using to model that addition problem. So they're not using the standard algorithm here. They're not stacking and adding 42 plus 25 to get 67. They have a different way. They're understanding how numbers are put together. I'm going to stop share. I'm going to attempt to use my whiteboard here behind me, so I'm hoping that you'll be able to see that as I come up. I'm not sure. I'm hoping that it's going to record.
Jen, before you step away, there were two questions in the
Thank you.
chat box. How much playing time should be allowed for students?
And so when we first give students the first set of manipulatives, when we're introducing students to manipulatives, we certainly want them to be able to explore those tools. So letting them play with them at first as an exploration is a great idea. So they might take a day in math class, and that's what they're doing, is they're exploring the new tools. And then we start to use those tools in a mathematical way. So we're sharing with them how they would use them as a resource. And then the tools are something that I actually might have available for them. If you have Inside Recess, it's a great way to let students play and explore with the math. And they might just be playing with the manipulatives, but you're getting them in their hands and they're getting used to them, so that when you do give them a math task, they're not going to necessarily play with them. They're able to attend to the task and use them as a tool because they've been able to get that play out of the way.
So I have the second question, and then a new one just came in. Is this resource free that you shared, the virtual manipulatives?
Yes, the toytheater.com is a free resource. So you could share it with parents because they may like those manipulatives, but you could use it with students, whether virtually or even once we get back to a classroom setting, you might be able to use that manipulative, the manipulatives with your students. But yes, the Toy Theater is a free resource, and there's all kinds of preset games in there that have to do with math and subitizing and all those younger strategies, but you also have all the tools that kind of span the elementary grades.
And then there was a question, what about touch math?
So touch points for math, there's many different sides of that. Some folks really love touch points. Some really don't love touch points. My take on that is, if that's what is helping students learn, if students can use that and use that successfully, then that's a strategy that they have. Eventually, we would love for them to move to more efficient strategies where they're not having to count out by touching the number. But if that's how students are working and they're working accurately and efficiently that way, then I would say let students use that. I know that for myself, when I get tired, I will use my fingers. I will touch on my fingers, or I might tap out a number. And that's just a strategy that we've come accustomed to, that we use because it's quick and efficient. So I know some sides are pro touch points, some are not, but I feel whatever works for students and what can help students move forward is a strategy for students to use. So thank you for the questions. Thank you, Michelle, for helping to moderate that. I'm hoping that you'll be able to see my board. So one of the other strategies that we came up to talking about, or will come up, is doubles. So once students have they've been working in their combinations of tens, we now start with doubles. And so I'm sure you understand doubles. 4 plus 4 equals 8. So if students know 4 plus 4, 5 plus 5, 6 plus 6, we can now use those as helper facts. So we might say, what is 4 plus 5? Well, if we know that 4 plus 4 is 8, and we know that 5 is 1 more than 4, then we can say that the sum has to be 1 more than 8. So it's 9. We can also use that in the reverse. If I had 4 plus 3, 4 plus 4 is 8. So 4 plus 3, 3 is 1 less than 4. So my sum is going to be 1 less than the double. So it's going to be a 7. So we call these doubles facts or double plus one, double minus one. And it's definitely a way for students to start making sense of what they know and moving forward to starting to use their number sense to help them with addition facts. And then we saw Graham Fletcher model the base 10 blocks. So it's really important to get those base 10 blocks out, have students using those blocks. But then once we get to a point where we are ready to do some writing, we need to understand how to model that. So we might use base 10 blocks to model 34 plus 72. So we might actually draw out these base 10 blocks. So I'm going to model 34, 10, 20, 30, 1, 2, 3, 4, plus 72, 10, 20, 30, 40, 50, 60, 70, 72. I can now put these together and I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. Well, I know something about 10 tens. 10 tens is 100. So I'm going to make a trade, and I can show that I've traded these in for a hundreds grid, and I have 4 ones and 2 more ones, so I have 6 ones. I like to write them out either in pairs of 2 and make 2 columns so that I can look at those and see them. That's called subitizing, when I can just look at a set and not have to count them all up. I also like to write them in either a row of 5. So again, we're going back to that 5 frame or a 10 frame, and I'm thinking about how I can see those numbers. If we're doing something like 39 plus 54, again, I'm going to draw that out. 10, 20, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 54, 1, 2, 3, 4, 5 tens, 4 ones. So student really has to understand place value and has to understand the connection between these numbers and the base 10 blocks. So I'm looking here, I need one more 1 to make this another 10. So I'm going to take it out of here and I'm going to make this into another 10. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I still have 3 ones. 1, 2, 3. So I have 93. So really getting students to understand place value, understand number sense, using those base 10 blocks. They will be using base 10 blocks. They should be using them in 2nd grade, 3rd grade, 4th grade. They may actually use them. Base 10 blocks are also very helpful when we get to subtraction.
Jen?
Yeah.
If you could make your dots larger and darker, we can see them. Right now, we don't see them.
Okay, thank you.
You're welcome.
We're actually going to move on from base 10 blocks to our open number line. So we all know what a number line is, right? We have a number line. Typically, number lines for our elementary students start at 0, or they start really at 0 and they move up. Students haven't looked at numbers less than 0 yet, so that's how we look at a number line in our younger elementary grades. But with an open number line, we can set where this number line starts. It's not a typical number line would have evenly spaced tick marks. On an open number line, it's actually not marked out, and a student can use that to show jumps in a different way. So if I want to show 37 plus 51, here's my number line, and I'm actually going to start at 37. So I'm going to make a mark, and I'm going to mark it out as 37. And I know that 51 is 5 tens and 1 1. So I'm going to jump by tens. So I'm going to add 10 each time. So from 37, I'm now at 47, 57, 67, 77, 87. So I've jumped 5 tens, and now one more hop to 88. So a student can make jumps based on the distances that they know where they could break it down. If I knew that 37 plus 20 was 57, I could make a jump of 20. So an open number line allows students to use what they know about decomposing a number and using those numbers as their hops. We can also use this for 3-digit numbers. If I wanted to, I can do 253 plus 321. Again, I'm going to start my number line. I'm going to start it at 253. So this is an open number line. I can start it wherever I want. I know that I need to add on 321. I can just make a jump of 300 because I know something about these numbers. I know that 253 plus 300 is 553. Because I know how to just add on my hundreds. I can then add on 2 tens or 20. I can do that. So 553 plus 20 is 573. And I have one more. So I get to 574. If a student didn't know how to add 20 to 553, they could make 2 jumps of 10. So an open number line allows students to use what they know to move their math forward. So if I didn't know how to jump by 300, I could jump by 3 jumps of 100, and then 2 jumps of 10, and then a jump of 1. Sometimes students also like to jump to a friendlier number. So if I had something like 49 plus 37, I start at 49. A student might say, well, I've got to jump 37. I'm going to jump 1 to get to 50. And now I only need to jump another 36. Well, I can do that. And I land on 86. So they could actually take apart their jumps in whatever way would make sense to them. So using 49 plus 1 more made sense to go to 50, because from 50 they could then add on a larger number. They still could have broken apart the 37 into 3 tens and 7 ones. But as they start to have more number sense and be able to add on larger numbers, they're becoming more efficient with that strategy. We also might think about compensation. So 49 plus 37, instead of using the number line, a student might go, I know that 49 is 1 away from 50, so I'm going to think about this problem as 50. I've added 1 to this guy, so now I need to take 1 away from this one. So 50 plus 36 is 86. Think about what students really have to understand about numbers and number sense when they're doing strategies like this. They're making sense of the problem and the value of the numbers versus just stacking them and adding them up and just following a set of steps. We then start to think about partial sums. So in partial sums, we're going to add together like place values. So if I have 345 plus 273, I'm going to break these out into the hundreds, the tens, and the ones. So I'm going to say 300 plus 200. So I've got 500. 40 plus 70 equals 110. 5 plus 3 equals 8. And so now I'm adding up 500 plus 110. So I have 610 plus 8 is 618. So they're taking apart those numbers and they are adding up by place value. And so this kind of comes right before you might see the standard algorithm come in. So if I was doing standard algorithm, I would have 345 plus 273. I'm adding my ones, so 5 plus 3 is 8. And when I think about this in standard algorithm, all I'm thinking about is 4 plus 7 is 11. Well, really, that 4 plus 7 is actually 40 plus 70. And we want students to understand that this isn't just a 4 and a 7, it really is 40 plus 70. And so when I get 11, really what that means is 110, right? I've got a 1 in the hundreds place and a 1 in the tens place here. That value is 110, but in our standard algorithm, it's a list of steps. 4 plus 7 is 11, so my tens number goes there and the ones goes there. I now have 3 plus 2 is 5, plus 1 more is 6. Again, we're talking about hundreds, so that 300 plus 200 was 500. I had this 1 that I took from my tens when I added them together. That's what I had carried here. So when we start doing partial sums, we're breaking those numbers out so students can understand where those numbers come from. We can then make a connection to our standard algorithm and why we do this as our shortcut. And that it's a list of steps, but they understand where those numbers come from. And it's really important that we work on not just showing our students tricks to do the math. We really want students to understand where those numbers are from so that they have a greater understanding of how to apply the math to a problem that's not always set up in the most standard way. Okay. So those are kind of how we might lead ourselves through the addition strategies. And I talked a little bit about fishing for 10 was one of the games that you might use. I'm going to jump back. Let's see if I can do this.
So Jen, I
Yes.
have a couple questions
Go for
from the
it.
chat box. So there was a question and several people have responded to this question in the chat box. Is there a reason why you didn't group your tally marks in 5s?
So those actually weren't tally marks. When we were doing it, they were base 10 blocks. And so it's a great question. And it's one of those that when we are switching from tally marks to base 10 blocks, we need to make sure that our students understand what we're using and that those represent those longs, those base 10 longs. So great question.
The other question was, what grade is the open number line introduced and used in? Where do we find that?
I think most often you'll see that introduced in grade 2, because in grade 1, students really are still using the number grid, as well as truly working on those combinations of 10. And so you wouldn't necessarily see the open number line until 2nd grade when you start working with more 2-digit numbers. And in 1st grade, if you're working with 2-digit numbers, often it's a 2-digit number and you're adding either a 10 or 20. You're adding that kind of number. It's not a tens and ones number that you're adding to it.
And then the final question was, where do you find fishing for 10?
So fishing for 10, if you Google it, you might find it. But again, it is just like Go Fish. So if I am, so if I'm playing, I've got my deck of cards now out in front of me here. So I've got my deck of cards, and if I have in my hand the ace, 2, and 7, then I would be asking for a number that would make a combination that would make 10. So if I was looking for something to go with the 7, I would ask for a 3. And so it's just like Go Fish. If the person had it, they would give it to me. I would lay down the 3 and the 7 and say that's 10. If they didn't, they would say Go Fish, and I would select another card. And anytime I got a combination in my hand that made 10, then I would lay that down. So if I had these in my hand, if I had the 9 and the ace in my hand, I would take that set out because that makes a combination of 10, and I would set it to the side. So you can use a regular deck of cards. If you take out the 10s, the Jack, King, Queen, and King, you could take out the ace, but if you took out the ace to play fishing for 10, you would also have to take out the 9 because there would be nothing to go with the 9. If you have numeral cards, you could certainly leave in a 0. If they had a 0 in there, you could leave in the 10 if you were playing fishing for 10, because 0 and 10 would be the combination that would make the 10. But if you only have a regular deck of cards, or if students only have a regular deck of cards, they would have to take out the 10 and above, but they would leave in the ace to go with the 9. Another game that you could play with students is it's like War. We used to play War. So you would, in War, you each flip over a card. Whoever had the 4 would get to keep both of them. Well, if you're practicing addition skills, what you could do is each person could flip over 2 cards, and I'm now going to add them up. So I have an 8 and an ace, so that would be 9. In this hand, I have a 9 and a 3, so that's 12. The person who had the sum of 12 would keep all the cards. So you would just add together those 2 cards that you had, and then whoever had the larger sum would get to keep the cards. If it was a tie, you'd flip 2 more cards, add them up. Whoever had the larger sum there would get to keep all the cards from both rounds. So you could even extend this game for older students that would involve a little bit of strategy. So if I wanted to, I could flip 4 cards. You could even start with 3, but I'm going to flip 4 cards. This is my hand of cards that I just flipped over. I have 2 7s and 2 3s, and I might want to now make 2 two-digit numbers, and I want to have the largest sum. So in this case, I would pick 73 and 73. These would be my two-digit numbers, 73 and 73. And now I would add these together, and I would get 146. And so you could see where this would definitely be something that you would want to do with either 3rd or maybe even 4th graders, because it involves some strategy. So if I'm playing against somebody, I draw 4 cards. Those were my 4 cards. The partner picks their 4 cards, and then they have to look. I picked a 6 and 3 4s. So now I have to think about what would give me the largest sum. So in this case, I don't have too much of an option. I would make the number 64 and 44. Now, there's nothing wrong with making 2 two-digit numbers and not thinking about what would give me the largest sum, but eventually students might come up with a strategy, like your 2 largest cards need to be in the 10s place because the 10s place is more valuable than the 1s place. So you would pick your larger cards to become your 10s place. But that's a strategy that you could have them work on as they're working to add out their numbers. So that's just a different game. It's a lot like War. It's a comparison game. If you use the program Everyday Math, it's called Top It, and they start Top It in kindergarten and work their way up. Different programs call it different things, but essentially it's just getting students to use the cards, to add the cards together, make numbers that they're adding together. They then are building in that comparison piece. Now, if you were at home, if a student was at home and you were doing a Zoom call with them, if they had a deck of cards and you had a deck of cards, again, take out the 10s and the face cards, you could then play against each other in a virtual meeting with them. So you don't have to be sitting side by side with them. You could play against the student. They would just draw their cards, show you the cards. you would show them your cards, and then you just set them to the side. And then one of the routines that I wanted to share with you, let me see if I can share my screen again here. So this was the game idea. Again, using the deck of cards, taking out the 10 through the king, flip the cards in pairs and add. The larger sum keeps the cards. You could also flip 4 cards, making 2 two-digit numbers and adding. The person with the largest sum keeps all 4 cards. You could even change the strategy and ask them for the smallest sum. So they have to think about what cards would give them the smallest sum, but you would decide that before you were playing. So the other routine, so that's a game. One of the routines that might have students just practicing is a number of the day routine. So if you look at this sheet here, the number of the day is 136. So you could do this, you could adjust this for the age group that works best for you. If you were in first grade, you might have students looking at smaller, like 2-digit numbers, start with single-digit numbers. But notice they're finding different ways to write this number or to model this number. And they're not all just addition problems. They might do an addition problem like right here, 100 plus 30 plus 6. But this one is 13 tens plus 6 ones, or 12 tens plus 16 ones. Here they modeled the base 10 blocks. Here they broke out all the tens. So they're not actually all the tens, they broke out 7 tens. So they have 10 plus 10 plus 10, 7 times, plus 66. You might say 10 tens and 36 ones. So they even got into, this one has a multiplication problem. But if you just asked your students to give you even 5 ways to make a certain number, that may be just a way to get students to look at breaking apart numbers and how numbers are put together and building on that number sense. Because in all of those strategies for addition that I shared with you, all of them rely on number sense and how you break apart numbers and how you think about numbers. So it's really important to get students familiar with different ways to represent numbers. And so even if you're not the classroom teacher and sharing this with your whole class, but if you're working one-on-one or in a small group, this is something that could easily be done while students might be coming into the room and getting settled. It could be, here's a sticky note and here's your number. And maybe a different student has a different number and they're working on whatever's right for them at their own, for their own skills that they're working on. But you ask them, find 5 ways that you might represent this number. And so it's just something to get each kid thinking.
Jen, we have
Yes.
a couple quick questions.
All right.
Could you please define subitizing again for us?
Sure. Subitizing is when I can look at a group of numbers and recognize that group of numbers without having to count them. So if I look at, for instance, the side of a die, and I see the number 5, when I see that pattern, I don't have to count each one of the dots, 1, 2, 3, 4, 5. I know that that's 5 just by looking at it. And so we want students to be able to look at things like 2, 4, 3, 5, 6 in different combinations, in different ways, and to recognize those numbers without having to count each one. So good question.
Perfect. The next question is about the slides. Will you be sharing the slides after we're done?
So you can always access the slides that I shared through the video. So we are recording it, and I know last week I was able to get the video up by the next morning, by I think 8 o'clock, 9 o'clock. I had it up on the website, so you can find the video in lots of different locations. If you got into our meeting today, you had the Zoom link and password, and so I will also link the video right in that document. You can also find it on the math landing page on the DOE website, and you can also find it on the DOE website under the COVID-19 for teachers. When you go to the for teachers, there's actually an area that says professional learning for ed techs, and when you click on that, that'll be linked in there as well. So the video is a YouTube video. You can pull it up, you can pause it, you can take a look at our whole presentation all over again. I know everything happened so quickly. We have such a short amount of time to do that.
So this next question, they want to know how long does the video stay active on the DOE website? And I'm not sure of that answer. I think it's as long as we leave it there.
I think it's as long as we leave it there. And if you got into the meeting today, you will always have access to the document that has our Zoom links. And so if you bookmarked that, you can go back to it, because I will leave it in there, and that document just sits in my Google Drive somewhere. So you'll have access to it. The video itself is actually part of the DOE's YouTube site. And so it'll stay there. It's on YouTube now, or will be on YouTube once it gets posted. Any other questions, Michelle? Did we kind of get through most of them?
We got them all. I've been writing them down, and when you pause, I've been throwing out the ones that needed to be addressed.
Excellent. Thank you so much for doing that. So I will now share with you